Now we want to take what we know about solving systems of inequalities and apply that to some applications. In example 11, Caitlin sells drawings at the county fair. She wants to sell at least 60 drawings and has portraits and landscapes. She sells the portraits for $15 and the landscapes for $10. She needs to sell at least $800 worth of drawings in order to earn a profit. How many portraits and landscapes could she sell and meet her goal? First thing we need to do is translate this information into some inequality statements. We know that she wants to sell at least 60 drawings. That means if we let the number of portraits she sells equal X, number of landscapes equal Y, that combined number needs to be at least 60, so greater than or equal to 60. Then we're told some information that she needs to sell at least $800 worth. She makes $15 per landscape. Portraits she sells for 15, landscapes she sells for 10. Meaning we would have the inequality 15x plus 10y has to be greater than or equal to 800 so that she earns enough to make a profit. Now we can graph this system of inequalities. And using the hint that we're given in the problem, we can adjust the minimum and maximum x and y values. We'll change this to -10 and our maximum x value to 70. We'll set our minimum y value to be -10 and our maximum y value to be 90. This lets us see that region of overlap. And what we're asked to do is identify how many portraits and landscapes she could sell to meet her goal. We have an infinite number of solutions again, because any point in this shaded region or along those boundary lines that cover the shaded region are going to be possible solutions. One thing we do need to keep in mind, though, is that both our x and y values need to be non-negative. She can't sell a negative value of paintings, so as long as we're plugging in a positive value or a non-negative value for x and y that's somewhere in this shaded region, we have a solution. But two different people could obviously pick two different answers. For our purposes, we're going to pick 45, 20. That's one possible solution. That rests in that shaded region. And what this means is that if she sells 45 portraits and 20 landscapes, she'll have met her goal. There are other ways she could meet that goal, but this is one way, by selling 45 portraits and 20 landscapes, that she would sell at least 60 drawings and have earned enough to turn a profit. In example 12, we're mailing Christmas cards and packages. We want to keep our mailing costs to no more than $500. The information that tells us about how those costs accrue is that the cost of mailing a card is $3 and the cost for mailing a package is $7. So we pay $3 times every card that's mailed plus $7 times every package. That amount has to be less than or equal to $500 to stay on budget. And the other information we're given is that the number of cards needs to be at least 4 more than twice the number of packages. That means that X needs to be at least, so greater than or equal to, 4 more, so 4 plus twice the number of packages. 2 times y. We can graph this system of inequalities. And then adjust our x and y values to be from -10 to 90. And from -10 to 80. Those values let us see the picture, see this overlapping region. And again, we just want to pick a single xy coordinate pair that's in the region, the solution region for this system of inequalities. In this case, I'm going to go with 80, 20. But we could also choose a variety of other answers like 10, 0, anything that's in this range. But if we went with a solution point of, or a solution pair of 80, 20, that would mean sending 80 cards and 20 packages would meet her goal. But again, there are other correct answers here. We could also send, for instance, 10 cards and 0 packages. That would keep us on budget and also meet that requirement of the number of cards being at least 4 more than twice the number of packages.